Hello everyone, and welcome to today's webinar, Biosafety Enclosures and the Automated Lab, Steps for Success. I am Jennifer Woods of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Labconco. To learn more, visit labconco.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Send. We'll answer as many questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have any trouble seeing or hearing the presentation. This presentation is educational and thus offers continuing education credits. Please follow the process to obtain your credits by clicking on the Continuing Education Credits window. I'd like to now welcome our speakers, David Wasescha, Director of Biosafety Products at Labconco Corporation, and Simon Fogarty, Director of Application Sciences at Tecan. David and Simon, you may now begin your presentations.
Thank you, Jennifer. Good morning, good afternoon, everybody. What I'd like to do is do a short presentation first before David takes the floor. And talk about some of the sort of main considerations for containment of automated liquid handlers. So, firstly, when you're looking at containment, you as an instrument owner, you've got two real options. Firstly, you can have a simple hood that sits on top of the instrument. These can be connected directly to in-house exhaust, or come incorporated with simple Hepa or charcoal filters, depending on whether you're dealing with biologics or chemicals, and can provide filtration of the air after it's been sort of handled from the instrument, either blowing air down onto the work surface for a clean air or an extraction-based system. The second option you have is a fully enclosed system. These offer a lot more flexibility in terms of having a bigger area that you can put plates and tubes, etc., down in front of as you're loading the instrument. It can house additional components such as plate carousels, which you can see there on the right-hand side of the photo on the right, the instrument on the right. You can also incorporate other integrated devices behind or below the liquid handler and build a much larger system. These are obviously those sort of more custom designed, but they are an option for you. Obviously, also the other consideration to have when choosing these is what space is available in the lab. The other major consideration, and David will talk a lot more about this in his presentation, is to think about it in airflow. You can't just put a liquid handling type instrument into a standard hood and hope that it'll work well. Regular laminar flow hoods are designed for a small number of obstacles in there, such as media bottles and flasks. When you put in a large instrument, you have to consider the instrument itself and how the airflow will work. And that's very much part of the design of the types of hoods that we offer and put together. You've also got to consider the accessibility. There's two types of accessibility are needed. The daily operator access, where you're going to be loading in plates, tips, reagents, etc., and then physically taking those out at the end of a run. You've got to make sure that the operators can reasonably access all parts of the instrument and the work deck. Oftentimes you'll have, and you can see it in the photo here at the bottom, at the back, plate hotels, hotels for tips, etc. Those have got to be sort of realistically accessible by the lab staff. You also need to have less routinely needed, but still important, that access for engineers to provide routine maintenance and repair as well. So you see in this system, there's a lower door for daily access and routine use of the instrument, and larger doors at the top and at the side as well for actual service and maintenance of the instrument. So again, this has to be sort of thought out in your design. For many of the instruments, we'll actually take off our safety doors when we install these into a hood. The reason for that is to allow good airflow within the instrument. And we'll often end up replacing the safety interlocks on our instrument with safety interlocks on the actual hood and enclosure itself, and wire those into the operating system of the instrument. So you maintain that safety lock system, but it's actually changed from being directly on the instrument to being part of the actual enclosure itself. And again, you know, this is an important aspect of the design of the hood systems that you'll need to purchase. Cleaning is another key consideration. With a large, expensive liquid handling instrument inside a hood, you can't just bomb it with formaldehyde like you would do for a regular laminar flow hood with nothing in it. You can wipe down the instruments with something like 70% alcohol. And for our liquid handlers, we recommend hydrogen peroxide vapor. But you do need to be careful about what you select. You do need to have that as a consideration in your design of the systems you're going for, the work you're going to be doing, and the cleanup protocols that you need to put in place to ensure that not only you're able to sort of keep the hood and the instrument clean and decontaminated, but also that you don't do any component damage to the instruments. And finally, there are two answers that you should have at your fingertips when you first start looking at enclosures and the types of hoods you need. Know your biosafety level that you need to achieve. Both us and Labconco can work with you and define a system that will meet those needs, but we'll take our guidance from you. You should, as a user, know what cells you're handling with, what chemicals, what requirements you need. The second question, and it's a trivial one, but it catches people off guard. And there's nothing worse than forgetting to address this and discovering on delivery day that the ceiling is too low. But make sure you know how tall your ceiling is. More importantly, also make sure you know if there are any restrictions in place height-wise related to how close enclosures can be to the top of the ceiling, and also any restrictions with regard to how close enclosures can be to venting and any other services within the ceiling. We have a number of design options that can address different ceiling heights, but this, how tall is your ceiling and what are the restrictions on things like venting will be the second question we ask. And with that, I'd like to say thank you and hand you over to David, who will go into some of these aspects in much greater detail.
Thanks so much, Simon. Thanks everyone for joining this morning or afternoon, depending on where you are. I'll click through one last slide. Thanks again to Tecan for joining this presentation. At this point, I want to talk a little bit about some of the opportunities for integration of automated instruments into larger enclosures from Labconco. And I'll cover a lot of the considerations that you need to take into account, just like Simon covered as well. And we'll also look at some options for containment of different platforms. So the first thing, just to touch base on what Simon was discussing, is really understanding the adherence and the guidelines that you need to comply with to ensure that your laboratory is carrying out all of its operations safely. And so for many of you, these are answers that come to you in the form of skilled recommendations from your biosafety officer or representative in environmental health and safety. A lot of the guidances typically come from well-known organizations like the CDC and its BMBL, which just received an update to the 6th version. And also the other organizational guidances like CDC guidelines. So just jumping ahead now, so just some of the organizations that are out there, again, CDC, World Health, ABSA, all great sources of information. You'll also find the ISAC guidelines for flow cytometry are another great spot to look if you're looking for help with cell sorter information. And then certainly institutional guidances as well. So if your organization has additional requirements that go beyond these documents, it's important to look at those and check with and consult with your biosafety officer on site. As Simon was saying, there are a handful of different opportunities for containment out there. In the form of Labconco's products, those are the next three that'll be displayed on this slide. It involves, most simply, is a clean bench or a laminar airflow hood. This is a downflow. Sometimes they exist in horizontal flow designs, and many liquid handler instruments out there have options for these to be purchased fully integrated. It's worth mentioning, however, though, that the only protection that is provided by this type of enclosure is product protection or sample protection. So while you can achieve the elimination of cross-contamination and room contamination of your samples, there's no protection for users. On the other hand, there are negative pressure containment options out there for biological hazards. These are typically referred to as Class I BSCs, as defined by the CDC's BMBL. And at the same time, also a more simplistic enclosure, providing just personnel protection for a user, so they're able to contain biohazards and other materials of particulates, with particulates, but they offer no protection from outside contamination or cross-contamination in the enclosure. So for sensitive assays that require aseptic conditions, these can be problematic. So the last and perhaps most prevalent biosafety enclosure out there is what's known as a Class II Biosafety Cabinet or a Class II Enclosure. And these marry the principles of clean benches and Class I BSCs to produce both personnel and product protection. And that creates a safe environment that remains aseptic. Also worth noting, Class I and Class II BSCs are all suitable for BSL-2 work and above, with consultation from your responsible safety officer. But want to just note that it's really important to look at that component, just as Simon had mentioned earlier, that is a piece that you need to understand, and Liveconco and others cannot provide guidance on which is the right level of safety for your organisms. Now, looking at standard Class II biosafety cabinets, these have been around for 50 some odd years. We know they provide personnel and product protection, and then, of course, environmental protection by not letting any biohazardous materials back into the laboratory. And really, Class II BSCs are designed for manual work. So they're designed to be regularly used by a human inside the hood and to handle things like cell culture flasks, reagent bottles, and other things that are smaller in size. If we visualize airflow within the enclosure, you can see on this slide, you may have to click play if it's not already playing, but you can see the downflow smoke within the cabinet. This is representative of unidirectional air, or sometimes laminar air, and it represents a clean, straightforward path of airflow downward in the cabinet. This is the principle that helps keep things clean as it comes out of the Hepa filter. Also helps to ensure that there's a limited cross-contamination or no cross-contamination as the airflow sweeps contaminants and pulls them into the air vents at the front and back of the hood. So as you can see with a user's hands in there, the laminar flow is not heavily disrupted, but if you take up that space with a large instrument or large materials, it can readily disrupt that airflow and restrict its pathway to the vents, which means that it can cause turbulence, and that may impact the samples, or worse, potentially impact the safety of the user. So if we look at on the screen is a Tecan Evo platform, and roughly these units are about 30 inches in depth. And if you look at the inside of a typical biosafety cabinet, across all different types of models out there, you'll see a number of dimensions listed, but the working depth is typically representative of the work tray or the actual space available in the enclosure. And even though some instruments may fit into a biosafety cabinet, knowing the compatibility and the dimensional fitment of that unit inside the hood does not necessarily ensure that airflow will remain safe. Certainly, if you're a safety officer on this presentation, you've seen an overloaded fume hood or a biosafety cabinet, and that is one of the most disruptive practices to the airflow that ensures the product will function correctly. So as you compare the sizes, it's really important not just to look at the available dimensions inside the hood, but the available dimensions plus an envelope around the instrument to ensure good containment. To look at this a little bit more closely, here's a couple of examples of some instruments. On the left, there's a liquid handler. On the right, it's an automated bioreactor. And many times, the dimensions of the product will fit within the enclosure, but may block really important parts of biosafety cabinets in particular. On the left, you can see this is the smallest configuration that this instrument allowed, and is while it does sit inside the enclosure and can operate functionally without any disruption from the sash, it covers the front airfoil, which means that the biosafety cabinet itself does not have the ability to properly function and contain while keeping samples within the enclosure. On the right, this is a bioreactor from Sartorius, and this instrument is actually capable of performing inside the biosafety cabinet and can contain, but we only know that with most instruments after some thorough testing, things like smoke airflow studies and biological containment challenges. So it is keen and really important to look at the instruments that you might be using and consult with the manufacturer of your biosafety cabinet before progressing. So if we look at overcrowding of a biosafety cabinet, really two factors come into account. And the first one is the size, and the second one is the shape of the instrument. Certainly, the instrument has to fit inside the biosafety cabinet to be a successful installation. But after that, you also have to ensure that the smoke or the airflow is going to generate a smooth path around the instrumentation. In this image, this is a view of a laminar airflow product from Labconco. And if you click play on your own, you will be able to see some of the smoke flowing through the enclosure around this large item. This is actually a large freeze dryer. And while generally the performance of the enclosure was compatible with this equipment, you can see the air has to cascade around that device, and in turn does pose an event that creates some disruption and turbulence where the airflow slots are. So it's really important to take note of large equipment inside of enclosures for these types of challenges. Additionally, it's important to look at the limitations that come with robotics inside Class II enclosures. So as you know, there are things like a glass sash that's a protective barrier, and sidewalls that also just ensure the cabinet contains and is robust over its life. But that poses a lot of inherent challenges for robotic systems. So certainly with liquid handlers and other instruments where there's a lot of access requirements to load samples and service, they can be obstructive. And furthermore, on some biosafety cabinets, there are issues with mitigating heat. The most common type of biosafety cabinet is a type A2, a Class II type A2, and it recirculates a portion of its air, which also means that it will recirculate a portion of its heat output. And for instruments, especially cell sorters and flow cytometers, that can be problematic. Also, just accessibility, again, not just for loading samples, but for maintenance and regular PMs. As you're thinking about addressing the service life of the instrument, making that easy for the servicer to come in and complete their job can be a real challenge in a biosafety cabinet when the instrument may be very heavy and loaded inside the enclosure and cannot be easily lifted out with just one person. So Additionally, just looking at when you're incorporating those instruments into biosafety enclosures of all types, it's important just to look at the footprint of the enclosure. Also look at the user accessibility issues. As I mentioned, on a typical biosafety cabinet, you have left, right, and rear walls that are all stainless steel construction with limited ability to access instruments from the back and sides. Also, a key thing to consider is the work surface weight limit. On a traditional biosafety cabinet listed to NSF 49, the work surface will be tested to a 50-pound weight load. Some manufacturers allow for more weight. Labconco does as well, but it's important to address the amount of weight, where it's going to be positioned inside the biosafety cabinet, and how the robot or other automated system is going to be behaving and redistributing weight as it operates. So checking with the manufacturer can help out with those questions. Also, pass-throughs are a really important consideration to make. Many times an instrument can be bought and not thought about the service requirements for it. So not only power, but vacuum lines, fluid lines, and other types of support must be considered before purchasing a biosafety cabinet. And failure to do so may mean that you result in an inability to run the cables out of the hood. So there are options to do that in all types of biosafety cabinets, and they're definitely the preferred way to pass cable in and out of the hood, as the front is not a solution that is safe. Just to highlight service accessibility, this happens to be a cell sorter, and the weight of this particular instrument is over 200 pounds. So imagine trying to access that with a blocked off rear wall. It can be quite difficult. So Liveconco has recently worked with several manufacturers of different types of lab instruments to come up with an enclosure that meets a lot of these challenges. We call it the Logic View. And really, in designing this product, we wanted to marry all of the challenges of Class II enclosures, both small and existing large enclosures, and really highlight a couple of key features that address safety, convenience, and intelligence expectations for all of you using these automated instruments. So just looking briefly at the enclosure, you can see it's quite a bit different in size and shape. It is a console-style single unit that rolls off of on a base stand that is built into the system. It's a Class II enclosure, so that means that it's providing both user and product protection, and also provides glass windows on all sides. So in its design, you're able to see any automated instrument performing no matter where you are in the laboratory. And that's really an important step, not only for just being able to see all of the parts of your instrumentation, but also to see it from a distance across the lab. Certainly as automation systems run without user input or interaction, it's important to understand and quickly glance and see that the system is running safely. Also, just on the note of accessibility, many times automated liquid handlers can be several hundred pounds, and to be able to support access without completely dismantling the system for service, this unit is provided with both a front and a rear fully loading sash. The dimensions are also quite large as well, and you may think, well, my automated system is maybe 25 inches tall max. Why do I need anything more than 26 inches? And really, that's the component that matters most to the performance of a Class II enclosure, is ensuring that the airflow coming out of the product is not turbulent as it cascades around the automated instruments. So looking at the airflow, just representing how airflow is moving through this design, the air is entering through the top of the enclosure for the supply HEPA filter and pushing down through the work surface after being passed through HEPA filters. On the left and right side of the unit, there are inflow arrows, and those are the protective arrows that airflows that keep users safe during operation. This unit has an 8-inch sash opening that runs the full width of the instrument to allow for full access to all of the parts of the instrument during use. And to keep users safe, it keeps a minimum inflow of 105 feet per minute, just like a Class II biosafety cabinet. The air is also exhausted through the lower portion of the enclosure, and it goes back into the laboratory, or can be vented, especially if you're using something that has an unpleasant smell or is perhaps warranting the use of exhaust for a different reason. To make sure that these enclosures perform, there's a lot of work that goes into performance challenging, and that's done in a biosafety cabinet by way of a biological challenge. The methodologies used for biological challenge assessments are largely dictated by NSF Standard 49 and involve the administration of biological spores across the work surface into the cabinet and then also out of the cabinet. So these are just a couple of representative images. Labconco performs these tests here in addition to NSF as well for other types of enclosures, and regularly evaluates the performance of the products to ensure that they're containing under difficult practices and principles and settings that users may be using the enclosures in. Controlling the system is also really important as well. The interface on a biosafety cabinet is really the hub for users to understand what's happening with an enclosure, whether the filter life is needing to be replaced, understanding alerts and alarms, and doing so with screens and images that help quickly resolve images rather than just simple beeping noises and difficult to understand alerts. So that's done on our platform using the MyLogic operating system. As Simon was discussing, it's also very important to consider the impact that the enclosure will have to an automated liquid handler that has panels. And so when those panels come off, the safety interlock method that was there provided by those panels is removed. And to correct for that and to still maintain that level of safety, that safety factor, it's important that the enclosure provides an ability to have a safety interlock. So this platform uses the screen in a complex system to be able to speak with liquid handlers and other automated systems so that when the sash reaches a opening position, it's also able to pause the robotic system and prevents users from being harmed. When these instruments are in a complex building environment, they also may sometimes need to be connected to a building management system, and that can easily be done with this platform as well. Some of the other things, perhaps less pertinent to safety, but more important to comfortable use with enclosures, is ensuring proper knee space underneath the enclosure. And that means being able to reach in and safely position your body to load samples in and out of the system. And also accommodating the other pieces of equipment that go with the liquid handler or an automation system for support. So this particular logic view includes a standard mounting system for Ergotron computer arms, which are regularly provided with automated instruments. And also the adjustable nature of the work surface is quite important. We often see our users of biosafety cabinets processing hours of cell culture work a day, finding ergonomics to be a key factor in their comfort level. And so this enclosure also has the ability to adjust upward or downward depending on how the users prefer to set the enclosure in the laboratory, and also just depending on the interaction requirements with their liquid handler. I mentioned weight earlier, and that's another key factor, not only just for support of the instrument, but also ensuring that the enclosure does not flex or cause inaccuracies with movements like pipetting or other interfaces and integrations that are going to happen between liquid handlers and other instrumentation. So the robust nature of a work surface is really, although unseen, is quite important to the operation of these systems. And so on our system, it's able to support up to 750 pounds on the 6-foot width, which is quite a clearance to allow for automated systems and all of the samples that are loaded onto them. Looking at pass-throughs is also a key factor in enclosure compatibility with automated systems. And so, as I mentioned earlier, without these being available with a standard biosafety cabinet in great capacity, it can be really challenging to safely pass cables in and out of the enclosure. So on the logic view, there are many opportunities for cables. There are pass-through cables for cords and cables, and those are gas-tight fixtures. There are also lines for gas and vacuum valves. And lastly, some instruments require quite unique pass-throughs. So if you are working with something that requires a vacuum line, or especially if you're working with a cell sorter that has a requirement for an airflow management system, those systems can be easily passed out with specialty flanges on our enclosures to allow for compatibility with all types of instruments. Sometimes your users may be finding that their system needs to be scaled up, and using robotics runners or other linear movement platforms to provide a larger, more complex environment for automation. And that can be accomplished regularly within the logic view, which has the ability to connect multiple units together to side by side. So you can see here this is a configuration of 2 units placed side by side, which allows for a total working width of over 12 feet. Additionally, wanted to revisit just the importance of looking at the compatibility of your instrument and an enclosure, and that starts again with looking at the instrument size requirements, looking at the ergonomic requirements for operation and service. So you can see here this gentleman is loading an Evo platform, and it's easy to do so because of the sash swings all the way open and provides great access to the interior. Also ensuring, again, cords, cables, and fluid lines are considered before purchasing an enclosure. With the logic view, you don't have to worry so much about compatibilities because there is quite a bit of flexibility, but if there are unique lines involved, it's really important to consider those dimensional requirements for those tubes. Also looking at waste, and this is perhaps one of the most important considerations with automated liquid handlers. Different ways to accomplish the removal of pipette tips from the systems. And as you're doing that, different liquid handling systems have different requirements. So it's best to consult with your automation specialist on what you'll be using, and then also working with Labconco to assess that the waste can be safely removed from the enclosure. We have different ways of doing that, but it includes careful assessment before purchasing a unit. Additionally, as you get these units into facilities, as Simon mentioned earlier, it's really important for you to consider the dimensional requirements for the doorways, for the loading dock, and other locations that you'll be receiving instrumentation. So with the logic view, the installation minimum requirement is 8 foot 6 inches. So it's often safe to say that a 8.5 foot ceiling will be compatible. More is obviously better if available. Also, doorways and hallways and the loading dock, as I mentioned, are really important to evaluate. The logic view can be stripped down to a much smaller size for passageway through standard doors, but at the same time, it's important to understand that before just receiving the equipment and pushing it straight into your lab. You may run into some challenges that require additional installation requirement. Also, power is really important, both understanding the power requirements for your automation instrumentation and also for the enclosure itself. Oftentimes, the larger the enclosure, the more energy required, and while not insurmountable, it does take careful planning, as oftentimes a typical 115 outlet for a small instrument may not be sufficient. Also want to talk about exhaust requirements for those of you who may be handling solvents or other things that may require exhaust. The logic view can be exhausted just like most biosafety cabinets, and to do so, it's really important to evaluate the mechanical system. Due to the size of an automation enclosure, there's a high volume of air that is exhausted throughout the system, and accommodating that on the building system and its exhaust is really important to evaluate before purchasing the equipment. And lastly, also important to visit the requirements for making sure that the unit can get safely into its space and also tested. So as you're considering these, it's important to understand the installation requirements. Livecongo certainly can help with some of those challenges, but also working on the testing of the equipment before it's used by a user. And what this means is that when the system is purchased, the automation enclosure, it should be put into place first and certified empty to make sure that it's operating correctly, and then again evaluated by the certifier after the instruments that are going to be placed inside of it are set. And that's to ensure not only that the unit was operating, the enclosure was operating safely first, but secondarily to make sure that the instrument that's being placed inside is properly functioning and not disrupting airflow significantly. Again, on the installation side, that means coordinating both with Labconco on the delivery of the instrument, also coordinating closely with the automation platform. We find the best integrations are where the users of the instrumentation are closely working with the automation enclosure and also the automation equipment providers, specialists, to ensure that all pieces of equipment arrive on time and are successfully integrated together. And again, test the unit before it's loaded with automation, and then again at the delivery and completion of installation of the automation system. All right, that is the end of my slides. I know we've had a couple of questions, so thank you again, and I think we will dive into the questions now.
Thank you, David and Simon, for your informative presentations. We will now start the live Q&A portion of the webinar. If you have a question you would like to ask, please do so now. Just click on the Ask a Question box located on the far left of your screen. We'll answer as many of your questions as we have time for. Let's get started. Our first question is, do we need a biosafety enclosure for our COVID samples? We are running both Abbott ID now and PCR assays.
Great question. Yes, if the virus has not been inactivated prior to testing, it does need to be contained in a biosafety enclosure that provides personnel protection. So while that may be a Class I enclosure, oftentimes the sensitivity of those tests is strongly warrants the use of a Class II Biosafety Cabinet. So if you have those instruments, or if you're running a larger application with an automated liquid handler or otherwise, it's definitely warranted to place that into a Class II BSC, if not only for the clean air, but certainly for safety as well.
Okay, thank you so much. And we have another question here. Well, this person's asking, what does biosafety enclosure mean?
Yeah, good question. So the term is broad. When we're talking about a biosafety cabinet or a biosafety enclosure, we're talking about, at a minimum, something that protects the user. So it's going to be providing negative pressure airflow into the cabinet or enclosure to keep them safe. So that's why it is important to look at all biosafety containment options out there and understand what your requirements for the enclosure is. So if you have an expectation for personnel protection or user protection, you need a biosafety enclosure. But if you also have requirements for clean air, it's important to understand and also purchase a unit that is going to provide Class II airflow, which is protecting both the user and their samples. I noticed there's another question about biosafety enclosures requiring UV light other than wiping down with 70% alcohol. This is a really important question to consider with your biosafety officer, first for the organisms that you're going to be handling and ensuring that you're adhering to the recommended practices of your organization. But also looking at the enclosure and its compatibility to be disinfected with those different chemicals. This question mentions 70% alcohol, and certainly that's a pretty widely used enclosure or a disinfectant solution for enclosures and robotics, but not all things are susceptible to being fully disinfected with 70% alcohol. So important to first look at what's required for your organisms that you'll be handling. Secondarily, UV light, while commonly found in Class II biosafety cabinets, is not as common in large automation enclosures and oftentimes not available. And there are two major reasons for that. One is that UV light is only effective on surfaces. When it is effective, it is only effective on surfaces that it can directly shine onto. So when you have a large safety enclosure that has automation instrumentation into it, UV light is going to be inherently blocked by the large equipment. And a large part, if not most, of the interior of the enclosure will not be disinfected effectively by a UV light. So that is why it's typically not recommended for any time instrumentation is placed into any kind of biosafety enclosure. The other reason is that The enclosures themselves, again, lots of places and cracks and areas that are difficult to clean, but also the instruments themselves can be susceptible to damage from UV light. Things like fiber optic cables and data lines can degrade over time with UVs. So it's really important to look at the requirements for the instrumentation and really identify a good chemical disinfectant first and foremost as your primary form of disinfection.
Thank you, David. Our next question here is, what's the difference between BSC 2A and B?
Good question. So a Class II Biosafety Cabinet is, overall, it is a unit that provides personnel or user protection and also sample protection or product protection. Type A and Type B are subsets of the Class II Biosafety Cabinet family. A is very common on a regular traditional biosafety cabinet. A Type A2 recirculates a portion of its air in its function, while a Type B2 provides 100% exhaust to the outside. B2 cabinets are often purchased with the expectation that they run safer for users. The only difference, though, is that they exhaust chemicals to the outside without any recirculation. So if chemicals are going to be used, they can provide some protection additionally over an A2 that would be canopy connected. But generally speaking, it's reserved largely for chemical use only.
And how do we measure that a BSC is working properly?
So first and foremost, the measure of biosafety cabinet working properly is its initial certification after installation. That's typically done by a technician who's got lots of experience and training in doing that. They measure the airflow, that's the inflow and the downflow speeds. They'll also look at the leaking of the filters, and they'll challenge the filters to make sure that they are leak-free. They'll also make sure that they understand the automation system that's going to be placed into the cabinet, if that's going to be used, and evaluate that platform with smoke visualization studies as well.
And the next question is, we have a liquid handler that just barely fits inside our normal tissue culture hood. Is this safe to operate?
Good question. If it just barely fits inside, as a manufacturer of biosafety cabinets with lots of experience testing such installations, it is difficult to make a black and white answer. So the best thing to do is to first consult your biosafety officer on site, involve your regular certification professional who's going to be testing the biosafety cabinet as well, and then also consulting with the manufacturer of the biosafety cabinet and with the manufacturer of the instrument that's going to be placed inside. There are fairly inexpensive tests that can be run using smoke visualization to assess containment. However, the only full dead set way to ensure that the cabinet is operating safely is to use a biological challenge assessment, which typically is performed at the manufacturer of the biosafety cabinet site.
Great, thank you so much for that answer. And our next question is, what does BSL2 mean?
Good question. So depending on your location around the world, you may have different requirements when you are adhering to biosafety considerations around the world. So WHO guidelines or CDC or others. And each one of them will have classifications for the organisms that are going to be handled, their risk group that they participate in, and then their subsequent requirements for the facility and instrumentation and equipment that are used to handle those organisms. But typically, at least in accordance with CDC in North America or in the United States, BSL2 organisms are the first level, minimum level that user protection is required in addition to protection for the organisms. The question that certainly your on-site biosafety or EH&S personnel can help answer as well if you have a question about a particular organism.
Okay, and our next question here is, when you join two of the large logic view units together, can you remove the center wall so the 12-foot bench is totally clear left to right?
Yes, you can.
Okay, perfect. And what differs with the airflow observed in a clean bench compared with the Class I and Class II BSC?
Sure. A clean bench is going to be providing clean airflow just over the work surface that's flown out towards the user. So someone who is working with non-hazardous samples will have the ability to work in a clean environment, but there is no protective environment that is provided to them. Class 1 BSC is the opposite. It provides protection for users, but it does not provide a clean airflow environment. And a Class 2 BSC combines the two and provides clean air and also user protection at the same time.
Great, thank you so much. And our next question here is, my liquid handler has a Hepa filter that came with the instrument. Does this Hepa filter provide any protection from biohazards?
It would not typically. Most of the instrumentation that's out there that includes HEPA filtration just provides a clean air style airflow and would not provide user protection whatsoever. Of course, there are a small handful of them out there that are providing user protection as well, but it's best to consult the provider of that instrumentation.
Okay, thank you, David. And our next question, let's see, is it safe to operate microbiological testing in a clean bench?
It really depends on the organisms that are going to be handled. So, for instance, something like a non-hazardous yeast specimen would be safe to handle in a clean bench, but you would absolutely not want to handle something that is pathogenic to humans in a clean bench.
Okay. And in a TB molecular lab, can we use UV light as an additional measure of sterilization?
Yeah, ultimately, this is a recommendation that you're going to work along with your biosafety officer on site, specifically TB, which is regularly quite difficult to inactivate due to its waxy cell wall, is going to require a heavy chemical disinfection first. UV light certainly does not hurt any type of chemical disinfection practices, but it really should only be used as a secondary measure after validation and disinfection with chemicals.
Okay, thank you, David. And we have one more question here. Let's see, what's the ideal way of, how should you move your arms, basically, while working inside a BSC? What is the ideal way to move your arms?
Yeah, anytime you're working in a controlled or critical airflow environment, slow, methodical movements are best. They help to eliminate disruption of airflow rather than swinging your arms around and disrupting airflow. So the slower and more methodical you can work, the better outcome you will have.
Okay, and we have another question that just came in. Does AHU have any effect on BSC efficiency?
Not exactly sure what AHU means. It may be air handling unit, which would typically be a generic term to cover the term or the instrument moving airflow in and out of a facility, like a HVAC system, would typically not have any impact on a biosafety cabinet's efficiency unless the person who's asking the question is asking about an air handling exhaust blower that would be supplying exhaust air from a biosafety cabinet. So in that case, if it was being, talking about an exhaust blower, then it would be, it depends on the type of BSC installation.
Okay, great. Thank you so much. Thank you, David and Simon, both of you. Do you have any comments, final comments for our audience?
Just wanted to say thank you very much for everybody who took the time to listen today.
Yes, likewise. Thanks so much, everyone, for joining.
Well, and thank you again, David and Simon, for your time today and for your important research. We would also like to thank LabRoots and our sponsor, Labconco, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today, and those submitted during the on-demand period, will be addressed by the speaker via the contact information you provided at the time of registration. This webcast can be viewed on demand LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, goodbye.